All right, so they want us to evaluate, for example, number 2, they want us to evaluate the square root of 1 plus cosine of x dx. But they don't want us to find the definite integral. They want us to explain that it's less than 3/2. Now, what I don't know, I mean, I could evaluate this in a calculator if I want to, but there's a property that says that whatever the minimum, whoops, I wrote the notation wrong. I can find the minimum area under the curve, or the minimum value of f evaluated from b to a, and that should be less than the area under curve of the function, which should be less than or equal to the maximum value of the function evaluated from a to b or b to a, however you want to look at it. All right? Does that make sense? Mm-hmm. So what we're looking for, this works because we're saying less than, right? So the area under the curve is less than 3/2. So I don't have to find the definite integral, I just have to show that it's less than. So what I want to do is I need to find this, and I need to find this, whoops, and I need to find that, and then this I don't need to find the definite integral. I just need to show that it's less than 3/2. So what is the absolute minimum cosine of x could be?
-1.
Huh?
Didn't you say -1?
-1. So the absolute minimum f of x would be -1. Now you could, and -1 and 1 could be like the square root of 0, right? Because you've got 1 minus 1 is 0, and then you take the square root of 0, which is just 0. Now what's the maximum that cosine could be? 1. So you've got the square root of 2, which is approximately 1.414.
Oh.
All right. Now this is 1.5. That's the maximum square root, or that's the maximum I could get for the area under the curve.
Okay.
Does that make sense? Okay. For the inequality. Now let's see. So now if I come in here, need the marker. And if I insert, so here's the graph of the function, and I just need to find the area under the curve of this from 0 to 1. Okay? So when you take the square root of this thing, it's going to spit out, it looks very similar to the cosine, but it's always going to spit out the positive or principal root. So what I'm going to do then, if I hit second trace, and I find the area under the curve with the lower limit of 0 and the upper limit of 1, you get 1.35, which is less than 1.5. Okay. Any questions on that? And then it's used for in manufacturing for tolerances. So sometimes that's a real simple function, the square root of 1 plus cosine of x. But sometimes we have very complicated functions, and so we just want to make sure the tolerance. In other words, we might be building a ball bearing, and the tolerance for whatever we're measuring is 1.5, and we want to make sure that it's below 1.5. So what we do is we might look at the function and say, what's the maximum value this function could be, and what's the minimum value this function could be, and then we prove it without going through all the complications of trying to integrate like a really difficult polynomial or something like that, okay? So that's it for that one.